So here we're going to do a vertex application problem. So we're maximizing area. So we got Farmer Clark here has 600 feet of fencing to put around a rectangular field. So I'm going to draw a rectangular field. Okay. And that field is subdivided into 3 identical smaller rectangular plots where 2 fences are parallel to the shorter side. So we've got the shorter sides, we'll call that X. And so I've got 2 fences that I'm going to use to divide this up into 3 equal parts. Do my best to make it look equal. That's about as close as I'm going to get. All right? So each of those have a length of X. Now, I know that if I add up all these sides here, all those sides need to add up to the 600 feet of fencing. Okay, so I got to figure out how long is this side here. Is it equal to X? No, it's not the same length as that right there, right? That's not the same length. So we need to call it something different. Let's call it Y. Okay, if that's Y, then that means this side over here is Y. So, like I said, we had to add all these up to get 600. So I have X plus X plus X plus X plus Y equals 600. So that's 4X plus 2Y equal to 600. Okay, I want to find the dimensions which maximize area. So I need to think about, okay, what is area? Area for a rectangle is area equal to base times height, which here the base is Y and the height is X, okay? But since we aren't doing multivariable calculus, we need to rewrite this in terms of X. So is there a way that I can rewrite Y as a function of X? Yes, I can solve this equation here for Y. Okay, and so I'm going to do that by subtracting 4X from both sides. And so now I have 2Y equals minus 4X plus 600. And I divide by 2, and I get X equals negative 2X plus 300. So what does this tell me? My area function is equal to negative 2X plus 300 times X. And I'm going to distribute the X in. This gets me negative 2X squared plus 300X. Okay? So what does this look like? If I were to graph this parabola would look just like this. Okay? Where we cross at X equals 0, and I think this would be X equal to 150. Right? Is that right? Yeah, okay. And so, if that were the case, my area is along this curve, okay? If I had X equal to 0, if this length was 0 here, then that would mean that I just had 2 walls that were 300 feet stacked on each other, and that has an area equal to 0. If my length here was 150, that would mean I just have 4 walls and they'd be all stuck together because there'd be no Y. The Y length would have to be 0. So that gives me an area of 0. So I'm looking for some X in between these where the Y value is maximized. Okay? The Y value is that A of X. So at what point is this going to be maximized? Uh-oh. All right. So at what point is this going to be maximized? The Y value is maximized here at the vertex. So how do I get the vertex? I do the vertex is negative b over 2a, comma f of negative b over 2a. Okay? So, my equation for area is a of x equals negative 2x squared plus 300x. So a is equal to negative 2, b is equal to 300, and c is equal to, well, there's no 0 here, so, but we don't even need that to get our x value. I do negative b over 2a, which is negative, and then I put a 300 in here over 2 times negative 2. And so that's going to be negative and a negative make a positive 300 over 4, which equals, what is that going to be? Is that 75? Let's check it out. 300 divided by 4 is 75. So that tells me that a side equal to 75 feet is going to maximize this. So if I wanted to get the dimensions, it's going to be a 75 foot by, or what are the dimensions for y? Well, what do we know? Y is equal to what? Y equals this. So I'm going to replace x with 75. Okay. And so this gets me negative 150 plus 300 equals 150. So this side is 150 feet. So that's 75, 75, 75, and then this is 150 right here. So the dimensions are 150 feet by 75 feet. Okay? So that's kind of how this application problem works for maximizing. You're looking for that x value here. You don't have to plug into your equation here. If you did plug into your equation here, what that would tell you is what the actual area is equal to. So if you were asked to find, it was like, what is the area? Then you would take a of 75 and plug it in, and you have negative 2 times 75 squared plus 300 times 75. Okay, and if I plug that in, so negative 2 times 75 squared plus, let's see, what was it? It was plus 300 times 75, enter, 11,250. Okay, 11,250 feet squared. All right. Now, people don't really talk in that type of unit, so you could do acres, and I'm not exactly sure what the acreage conversion is, but we could try it out. Ooh, not Pinterest. Oh my goodness. So let's try this. Convert 11,250 feet squared to acres. So that would be a little over 1/4 of an acre. Okay, so a little bit over 1/4 of an acre. All right. So that's usually people talking acreage when they're talking about land here. Okay. So an acre, 1/4 of an acre, that's not a bad plot for some livestock. All right. Good luck.